Hey guys, this is Mr. Sal. This question comes from a viewer on my YouTube channel, so I just thought I'd answer real quick. Well, however quick it ends up being, because solving systems of equations without using matrices, sometimes it just takes a little bit of time, so let's go and get started. Now, the first thing we're going to do here is we're going to number these equations. We didn't do that in the other videos, but I know in the past other students in my classes have said that they like to number them. I kind of try to color code these, right? So like my first equation I'm going to do in red, the second one in purple, the third one in green. And I'll keep them numbered so that we can kind of still discern the difference between these equations and also where they came from. Now the first thing we're going to do to solve this system of equations is choose two of the equations in this set of three. Now for me, I'm going to choose that top equation in red, and I'm also going to choose that second equation, the 3x minus y plus 4z equals 25. I'll put that in purple. Now you could have chosen any of the other two, but I'm just choosing the top two just because they're there. And you could choose the first and the third one. We're going to have to do it again, so for that one I'm probably going to choose the second and third one. Not that it really matters. So the reason why we've done this is to eliminate one of the variables, and it doesn't matter which one, x, y, or z, but we need to eliminate one of those variables in order to create a new equation with only two variables. So I'm going to ignore those other ones for now, and when we get this new equation, which will have only two variables, then we'll give it a new color and a new number, so again that we've made the distinction between this new equation that we will have and other ones that we will be using. Now, looking at these two equations right here, I don't really see any that are going to be easily eliminated. Okay, and because of that, I get to kind of choose what I want to eliminate, and I'm just going to choose to eliminate the x's. Okay, so you could have chosen to eliminate the y's or the z's. Now, keep this in mind as well. Is I'm choosing to eliminate the x's, and I need to keep this in mind because when I go back and create or choose two of the other, when I get the other two equations, I am going to also need to eliminate the x's. So the new equation that I have should only have y's and z's, and when I eliminate the other two, eliminate a variable from the other two equations that I'm using, I am also going to be choosing to eliminate the x's so that I have a new equation with only y's and z's. Okay, so to do this, and again I'm working in red here, I need the coefficient of the x's to be opposites. Now in purple I've got a positive 3 right there, which is good. We want that right there. But right now the coefficient of the x in the red equation is just a 1. But I want it to be the opposite of 3, which is negative 3. So to do that, I would need to multiply it by negative 3. Now, when I do this, I can't just change the coefficient of that specific x. I need to change the coefficient of all of the variables and terms, which means that I'm really distributing this negative 3 into all the terms in this equation, which would then give us negative 3 times 1x is negative 3x. Negative 3 times 2y is negative 6y. Negative 3 times 2z would be negative 6z. And this equals negative 3 times 4, which is negative 12. So this is my new equation. Of course, I still have the one in purple. And I didn't really have to do anything to that one, right? Because now I have coefficients of x, the x's, that are opposites. One is negative 3, one is positive 3. Now I said I was going to eliminate the x's, right? Which means that right now we're going to add each of the individual terms. Now the coefficient of that y in purple is a negative 1. So the x's do cancel out. That zeroes out. So I just put a 0 there so there's no confusion. Now for the y's I've got negative 6y plus negative 1y, which would be negative 7y. And for the z's, I've got negative 6z plus 4z, which would be negative 2z. And I've got to add the answers as well, negative 12 plus 25. And that should give us a positive 13 right there. So this is my new equation in orange, and this is going to be equation number 4. So I did what I had set out to do in that part of this problem, to eliminate the x's from equations 1 and 2 together to create a new equation without x's, so it has only y's and z's. So next up, what I need to do is use two other equations. Now, of course, we're going to have to repeat one of them, right? Which I'm going to choose just equations 2 and 3. And again, I'm going to be focusing on eliminating the x's. So I've got equations 2 and 3 in purple and green there. And again, I'm going to do the same process by eliminating the x's. And again, this will give us a new equation without any x's, but only y's and z's in the equation. So the same process applies to this one. I need the coefficient of the x's to be opposites, right? So I'm just going to, identifying the coefficients of x. The purple one, the coefficient of x is 3. The green equation, the coefficient of x is 3. They're the same, so I just need them to be opposites. What I'm going to do is I'm going to multiply that top equation by negative 1. Now again, just like we did in that last one, we're distributing it to all the coefficients and the answer there. And the coefficient of y right now is already a negative 1, so it's going to change. Sorry, that's an arrow right there. To show that it's changed. And the new change, since I'm multiplying all the terms by a negative 1 now, is negative 3x. Negative 1 times negative 1y is positive 1y. Negative 1 times positive 4z would be now negative 4z. And negative 1 times 25 would be negative 25. Now that green equation we didn't change at all, and it would give us coefficients that are opposites. So now that we have it like this, we can add all of the coefficients separately, all of the terms separately with their corresponding variables. And when I do that, for example, the x's, right? Again, that's going to create a 0 right there. But I need to do it with all the other terms. So the y's I need to add. 1y plus 2y would be 3y. And the z's, negative 4z plus negative 1z would be negative 5z. And this would equal negative 25 plus negative 4, which is negative 29. So I'm going to call this my equation number 5 right here. Now I'm going to separate these two, equations 4 and 5. So I have these two equations now, which I put on the left over here, in orange and blue, right? Those are my equations 4 and 5. Now this is a system of equations with two variables, which we've already seen how to solve. And you could solve it with elimination, substitution, or even graphing if you wanted to, but these are both already in what we would consider standard form. So I'm just going to look at these and solve them using elimination or addition, whatever method you want to call it. So in considering eliminating variables, I just look at these two and I think, well, maybe probably eliminating the z's would be a little bit easier. I don't know. I don't think that it's really one is easier than the other in this specific case. But I do need to eliminate them, one or the other anyways, and I'm just going to choose to eliminate the z's. Now again, I'm stressing you could eliminate the y's if you wanted to. I'm just choosing the z's just because. Now what that means is I need the coefficient of the z's to be opposites. So all I'm going to do is I'm going to take the top equation here, and I'm just going to simply multiply it by, I'm going to make this one a negative 5 here. Now what that is going to do, right, because I do need to distribute the 5 into all of the terms here, is it's going to make the coefficient of z a positive 10. So negative 5, let's just go through this. Negative 5 times negative 7y would be positive 35y. And then negative 5 times the negative 2z would be a positive 10z. And then negative 5 times the positive 13. So this equals, now it's a negative 65 right there. Now I do need to change the coefficient of the z in the blue equation, equation number 5. And to do that one though, I'm just going to multiply it by 2 because its coefficient is already negative. So this is going to keep it as a negative, but it should be the opposite of the coefficient of z in the orange equation. So I'm going to distribute this 2 into the 3 terms in this one as well. So 2 times 3y would be 6y. 2 times negative 5z is negative 10z. And this equals 2 times negative 29, which should be negative 58. Alright, I had to just double check to make sure I did that correct. So now that we have this, let's go ahead and add these two equations together. Now when I do this, it should give me an equation that I can solve because it should have only one variable, right? The z's should cancel out. So I'm going to add the y's. 35y plus 6y is 41y. The z's do cancel out when I add them together. And this would equal the addition of negative 65 and negative 58, which is negative 123, it looks like. So now, just to solve for y, all I'm going to do is I'm going to take that 41y equals negative 123. I'm going to divide both of those by the coefficient of y, which in this case is 41. So divide there by 41, divide here by 41. So again, that makes the coefficient of y a phantom 1. Y now equals negative 123 divided by 41. Appears to be negative 3 on this. So right now I just solved for one of the values, right? I got y equals negative 3. Now that I know y is negative 3, I can go back to one of these two equations in orange or blue and plug y in as negative 3, which will then allow me to solve for the z value. So I am choosing the blue equation, and I got the y right there. I'm just going to replace that with the negative 3 that we found as the y. So we'll just replace that there with negative 3. And all we're going to do is solve this thing, okay? So use this turquoise color to figure this one out. 3 times negative 3 is negative 9. So now I've got negative 9 minus 5z equals negative 29. And I need to zero out that 9, right? I need to isolate the z's in this case, so I would need to add 9 to both sides of this equation. And that gives us, or leaves us with the negative 5z equals negative 20. Divide both sides by negative 5 now, which would leave us with the 1z, phantom 1z, z equals 4 now. So I've got this answer too. The z, all I need is the x value. So from here, I got to choose one of my original 3 equations and just write it out. We're just going to write it out to start with. I am going to choose, well, yeah, sure, I'll choose equation 1. It looks like that's going to make x pretty easy to solve for. So this is what we have. Now we know that z is 4 and y is negative 3. So I'm going to replace that y and z with those respective values. And from here is just like solving a regular equation. I guess I'll do this one in green, sure. 2 times 4 is 8. 2 times negative 3 is going to be negative 6. I'm just going to make that minus 6. So I got x plus 8 minus 6 equals 4. Combining these two, I got 2. So x plus 2 now equals 4. I'll have to subtract 2 from both sides of this equation. And this shows that x equals 2. So we have those 3 values. And we could put them in an ordered triple, right? Where we know the x is 2, the y value is negative 3, and the z value that we found was 4. Like this. You could just say, or just leave it like it is, where the z value is 4, the y value is negative 3, and the x value is 2. That's okay. Now the last thing we should do on this one is just double check and make sure that it, because we just confirmed that it makes the red equation true. We should also check with the purple equation, alright? I'm just going to kind of, well, do this one in my head. I recommend using a calculator, but this shouldn't be too bad. So I got an x value that's 2, right? So 3 times 2 is 6, minus y is negative 3, so that's going to be 6 plus 3, which is 9. And then 4 times e, 4 times 4 is 16, 9 plus 16 is 25. So that's just good for us to check off that equation because I know it's true. The third equation, again, I got x is 2, y is negative 3, z is 4. So 3 times 2 is 6, plus 2 times negative 3, which is negative 6. So that'd be 0. 6 plus negative 6 is 0. Minus z, which is 4. So that's going to just be negative 4, is equal to negative 4. So that one also checks off. So we checked off all the answers just to make sure everything's good. And again, I would recommend using a calculator on those, but that concludes this problem. We already found the answer there. Again, hopefully this was helpful for you guys. Thanks for watching, and we'll see you guys in the next video. Have a good one.